Okay, so we're dealing with coordinate geometry. So up until now, the geometry we were dealing with, they were shapes, they were lines, they were points. They didn't have any particular position. So now we're going to look at positions on a plane, a coordinate plane. So that's a two-dimensional plane. So it has both an X and a Y axis or number line. Okay, and we came across this many times so far in our journey in maths. So this should not be a surprise. So it looks like this, and it will continue on forever in all directions. So you can draw it as much as you want. You can scale it as much as you want, depending on the question. But normally for exams, of course, they will more than likely have it drawn for you. But just make sure that if you are drawing one of these, that you do keep the scales the same. So for instance, if you're drawing it on a box plane, that if you leave two boxes between here and here, that everything, you must have two boxes all along that line. But you can change the scale for the y-axis. You can have one box between everything on the y-axis. They don't have to be the same scales. That scale is up to you if you're asked to draw it. But just make sure that each jump, including the zero here, is of the same length. Okay, so we have to be able to plot points or coordinates. So if I was given the point -3, 2, I need to be able to plot that point. And this is just revision for you guys. This is the x coordinate. So it's based off the x-axis. The second number is always dealing with the y-axis, or the y-coordinate. So the x-coordinate is -3, so that means I start here at -3, and then the y-coordinate is 2. That means I find where y is 2, and I plot my points. So sometimes a dot can be used, or a dot with an X through it could be used, or something like that. And then I would usually label that point. Okay, Shannara, label that point as well. So that would be an example of plotting a point. All right, so often they will use 2 points, and this is most of the work in coordinate geometry, is when they have 2 or more points, and those points form a straight line. So let's get a second point. Let's plot the point 0, -1. Okay, so 0 on the x-axis, so that's 0. -1 is here. So put a little x for 1, 0, -1. And they can ask to, if you join those 2 points, let's call them A and B. If you joined A and B, it would form a line, wouldn't it? So I can join A and B. I have my ruler to hand. I could. I can't find it, so I'll just go freehand. So if I join it, should form a straight line. Okay, so if you had a ruler, it'd be better than that. Okay, it forms a line. If any 2 points join together, are going to form a line. They're asked certain questions on that. So you should be able to find out what the slope or gradient of that line is. You should be able to find the distance between those 2 points. And you should be able to form the equation of that line. So let's look first of all at finding the gradient of that line. So the gradient of that line is how steep it is. So think about a mountain. If we have a mountain like that, and there's some snow on top, and you're going to set off and climb that mountain, the steeper the mountain, the harder the climb. So if it was a sheer mountain like that, you wouldn't be as happy as if it was a nice easy climb to the top, and that would do to be a bit happier. So the exact same thing works for gradients. The steeper the gradient, the larger the number, basically. This gradient Going up will have a positive gradient, and going downhill will have a negative gradient. So this would also be positive, and when you start to go down, it would have a negative gradient. So you read gradient or slope from left to right. So you always approach the mountain or the line from left to right. So if I look at my one I've drawn, if I approach it from left to right, it's downhill. So this gradient is automatically a negative number. So gradient of a line downhill is negative, and uphill is positive. And you always approaching it from the left, so the dude always climbs his mountain from the left side. All right, so how do I get a number for that then? This one doesn't look particularly steep. It looks like a relatively gentle gradient. So how do I put that in a number? Well, I need to look at the rise and divide it by the run. The rise will be the y-axis, and the run is the x-axis. So how far it goes over for how far it goes up. So a quick example for that is if it goes over just a little bit but rises, let's say that much, versus if it goes over much further but rises the same amount, that's a far steeper slope than this one. Okay, I didn't quite match that. But this slope is steeper and this slope is easier based on the amount of the fact it runs. So the run is important. The x-axis is important as the height of the mountain, let's say. So it could be a sheer drop or it could be a nice gentle slope. All right, so how do I do that? Well, I do exactly what I've done here. I form a right angle triangle between 2 points. You can pick any 2 points because the gradient's not going to change. Just I pick points that will give me whole numbers. So you might remember this from last year. If I get whole numbers, it's easy to count. So instead of dealing with 2.5 in your slope or whatever. So what is my slope here? So I count the distance. So from here to here is going to give me my run, and up here to here is going to give me my rise. And I'm just counting those numbers. So using my units, one unit brings me up here, another one brings me here, and another one brings. So there's a rise of 3. So 3 is the rise. What's the run then? 1, 2, 3. So I can use the scale if I want. I know it's back here at 3. So the run is also 3. So the rise over the run, or the gradient in this case, is going to be 3 over 3. Or we can simplify that to 1. Now remember, it is downhill, so it's automatically negative. So the slope or the gradient of the line I drew was -1. The symbol for slope is m. M is the mathematical letter used to signify the slope of a line, or the gradient of a line. So remember, slope and gradient are the same things. Gradient is used more often. Okay. Now, there's a formula that can help you get this every time. M for gradient is y2, so the second y point, take away the first y point, over x2, the second x point, take away the first. So what they're really doing is just getting the difference between the two x points, so how far the two x points are away from each other. So that's on the x-axis, what we just did before, the distance between the two, and then the distance between the two y points, which would be the rise over the run. So that's just the slope format of the picture we just drew. So if you get 2 points, let's go 1, 4, 7 minus 6. So if I want to find the gradient without drawing, I could draw this and get my rise over run, but I can do it without the picture if I use this. So this is x and y, x point and a y point. This is x point and a y point. I just need to say which is the first one, so let's call these the first ones, and which is the second ones. Call these the second ones. Okay, so how would I use the formula? y2 then, I just replace it, so y2 is minus 6, minus whatever y1 is, so 4, divided by x2, whatever x2 is, 7, and take away whatever x1 is, 1. This gives me negative 6 take away 4 is negative 10, 7 take away 1 is 6. I can simplify that down a little bit, dividing by 2, so it's minus 5 over 3, so the rise of the run. So this is, once again, a negative slope. It's a steeper slope than the last time because it's a bigger number. So it drops quicker, if you wish. And so this slope is minus 5 over 3. All right. So the slope can help us get the equation of a line. And usually it says in the form y is equal to mx plus c. Right. So the equation of the line is the set of like points. It's a quick way of writing the set of points. Instead of having to say every point along a line, you can say the set of points. So they're related. All of them are related by the slope and C. And C is where a line crosses the y-axis. Okay. So if I have a line, so there's my new line. First of all, I know this is a positive slope. Let's put in some points along it. Oh, this is a terrible scale by me, but you get the idea. Okay, so here's my line. I want to form the equation of this line, given the information that I have. Now, the equation of the line will include y is equal to something x plus something. I just need to fill in the something and the something. This would be the gradient, and this would be where it crosses the y-axis. So if I look at this and go, well, it crosses the y-axis here at minus 1, this line. So that means it's not no longer plus something, it's plus minus 1. Plus minus 1 is just minus 1. So now I can change that to something x minus 1. That's where it crosses, minus 1. Now I just need to fill in what the slope is. Now I have plenty of ways of doing that. I can use this formula up above, or I can draw my triangle. I'm going to draw a quick triangle. I just draw a triangle here. First of all, I know it's a positive slope because it's uphill. How many units across is it? 2, 1, 2. How many units up is it? It's only 1. So what's the rise? 1 over 2. So the slope of this one is a half. So y is equal to a half x minus 1. And that is it in the form. That is the equation of the line. That gives loads of information about that line. Any point on that line will satisfy this equation. In other words, if I substitute it in, 0 will equal 0 on both sides. So it will give me any point along the line. And I can kind of test that if I want. I could find any point along the line. In other words, I can find where would x be 2? If x was 2, what would the y point be? So I go half of 2 is 1. 1, take away 1 is 0. So the point 2, 0, when you subbed in 2, I got 0 out for y. That point is on the line. Then I can check, well, yeah, it is. Look, 2 is here, and 0, 2, 0 is that point there, and that's on the line. Okay, and that's a little test to make sure my point is on the line. You can test any point then you want. You can find where x is 100. I'll find the corresponding y point just by using this equation of the line. That's why it's quite useful. You can find any point along the line using this equation of the line. So you will be asked sometimes in the exam, it's quite a common question. They'll give a sketch like this, and they'll ask you, find the equation of the line in the form y is equal to mx plus c. And you will need to be able to use the y-intercept and the slope to form that equation. Okay. Now, sometimes they talk about parallel and perpendicular lines. Parallel lines, well, let's think about that. And I'm just going to think about it from a gradient point of view. If I think about a parallel line can never meet this line. So what would be the gradient of that line? So if I just drew a sketch of that, a line that never meets it would kind of have to go alongside it, going the same way. It would have to have the exact same slope, an exact same gradient. Otherwise, if it was anyway off tilt, it would eventually meet up with that line and cross it at some stage. So parallel lines can never meet. So parallel lines must have the same gradient. So if two lines are said to be parallel, they have the same gradient. That m would be the same. They might go through a different y value. You can see here it goes through a different y. This example goes through 1 on the y-axis. So it wouldn't have the same equation. It would actually have the equation, the parallel line would have the equation y is equal to, well, it has the same slope, half x. But instead of intercept of -1, this one goes through +1. So that parallel line, that one has this equation. A perpendicular line will have the exact opposite gradient. So think about it. If something is perpendicular, it completely hits it at right angles. It goes straight through it and makes right angles here. If this one goes that way, the other one goes definitely negative slope, because if this one's positive, the other one has to be negative in order to meet it at right angles. And it's actually the complete flip. So if one has a slope of a half, its perpendicular slope, buddy, would have a slope of -2/1. It'd have to go the opposite direction to catch it, and it would be, if this one is a gentle slope, this one would have to be a sharp slope. Okay, and that is perpendicular lines. Okay. And that is about it we're going to do today. So you will need definitely to know how to get the gradient of a straight line, so slope of a straight line. You will definitely need to know how to come up with the equation of the line based off a diagram, and possibly able to draw the diagram based off an equation when given. So could you be given that equation and draw the line? Well, that's what we look at tomorrow. But for today, that is it, and parallel lines. So what's your work for today? And this is going to be up on Manage Back in a second.